Hello guys, so I have started streaming and I hope that you all are fine. Just quickly let me check first whether I'm live or not. Okay, cannot see myself live. Just give me a moment to see. Okay, मेरे end पे it is streaming. Yeah, it's streaming, but yes, now I can see myself live. Great. Now I can see myself live. All right. I hope that you all are fine and everything is going well. Okay. I have texted you on the Telegram group as well regarding the class. Okay. You can see here. Okay. I have sent you the message. Cool. Eh? Alright, so what are we gonna do today? We will be starting with, let me see my phone. What are we gonna do today? All set. So yeah, what are we going to start with today, beta? We will be starting with the coordination compounds, right? Today we will be starting with coordination compounds, right? We'll be starting with coordination compounds. Okay, we will be starting with coordination compounds. Okay, this is nothing but coordination compounds and this is a one shot session. Okay, this is going to be a one shot session. All right, this is going to be a one shot session. Cool. So yes guys, before starting, let me just tell you something important. Okay, your schedule. Okay, what's your schedule? Let me tell you, like for 11th February and 12th February, I have scheduled something like long sessions for you. Like the schedule after 12th of February, you'll get to know soon. Okay, this is the schedule for today and tomorrow. Okay, for today, that is your 11th of February, for class 12. I have scheduled coordination compounds one shot, right? You can see here coordination compounds one shot. 11th February को ही class 12 के लिए means today only for class 11. Today for class 11 at 12 p.m. At 12 p.m. we have general organic chemistry part 1. ठीक है, we will be doing general organic chemistry part 1 on 12th of February for class 12. Same timing बच्चे 9 to 11 in the morning, 9 a.m. to 11 a.m. we will be doing surface chemistry. We will be doing what? We will be doing surface chemistry. Okay, we will be doing sorry, yeah, so we will be doing surface chemistry. And on 12th of February for class 11, we have scheduled from 12 p.m. to 2 p.m. GOC part 2. Alright, this is your GOC part 2. So this is your schedule for today and tomorrow. Be prepared 9 to 11 and then 12 to 2. So like we have great sessions for you and this is going to be really amazing. Okay, because all your doubts and everything are going to be clear. Okay, so yeah, let's get started. You can see here. Before starting, let me tell you my introduction. Bache, my name is Kirti Sharma and I have completed my graduation from University of Delhi and that too in psychology. Okay, in psychology. Okay, I am just sending the links again so that you guys would join. Okay, yes. Now, you know me already, right? Your chemistry educator, Kirti Sharma, and I have completed my graduation in psychology from University of Delhi. And it's been like 5 or 6 years that I've been teaching you guys, and the journey has been amazing. And now it's your turn to start, to begin. And class 11 students. Okay, this session is for class 12 only. So let's talk about class 12 only. Okay, it would be better for us. Let's talk about only for, class 12 students. Okay. So today, as you know, 9 to 11, although like the session became a little late because of some reason, power cut ho gaya tha suddenly. 9 to 11, we have a session for coordination compounds today. And tomorrow, this was 11 February, and 12th of February, we have a session 12 to 2 for surface chemistry, right? It is what? This is for surface chemistry, okay? This is for surface chemistry, okay? So these two chapters will be done for you from today to tomorrow, okay? So let's get started first, and then later on I will tell you like what are the different features that we have for you, what are the different plans that we have for you. Okay, but like you can see here, you can join us on Telegram, okay, so that you will get all the notifications and all the updates regarding the class. Okay, so yeah, this is nice. Join the Telegram group so that you won't miss any class. Okay, and moreover, like let us know when are exactly like your exams. Okay, so accordingly we will schedule further sessions. Okay, guys. Yes, all right. I have a little bit of infection in my eyes, and okay. All right. So let's first start with the oopsie. What happened? Right, here we were. Okay, so let's start with coordination compounds, okay? Yeah. Here it is. Coordination compounds, you can see, right? This is coordination compounds, right? You can see it here clearly, right? It works, right? So this is our coordination compound. So what is meant by coordination compounds? As you know already that we start the chapter with the applications always, है ना, कि जो like whichever concept we are studying, whether it's physics, chemistry, maths, biology, you must know like where is that concept or where we are using that chapter, right? Only then it is of your important use. So this is something very important. So yeah, let's start with the coordination compounds key applications. So you have seen Prussian blue color, which is often called as royal blue color. Okay, so now why is it called as royal? Like why it is so royal? Because like in ancient times, not now, in the ancient times, the source from where you extracted that blue color, okay, from where we extracted this blue color, that is royal blue color, or you can see the Prussian blue color, it was very expensive at that time, very expensive, it was very costly. So that's why like uska naam kya pad gaya bache, this is actually K4FeCN6, it's not this, it is K4FeCN6, it is K4FeCN whole 6, ठीक है. Now you can see that the structure of this coordination compound is a bit complex, right? It is a bit complex. So that's why these are also called as complex compounds. What else do you call it? You call them as complex compounds as well. You call them as complex compounds as well, all right? So yeah, this is the deal with coordination compounds. Let's look at some more uh what do you say, applications. Okay, so coordination compounds are extensively used wherever you can say pigmentation is required, wherever it should be, colored, all right? Wherever pigmentation, dye industry, colorations industries, they use coordination compounds extensively, okay? Because coordination compounds are colored generally. Why? What are they? They are colored, all right? And I have like already told you that the D block elements, or I would say the transition elements, they form coordination compounds, right? DD transition की वजह से, correct है? And that's why they are colored. So only they form complex compounds. This property also we have done in D and F block, right? That chapter is also in your syllabus. If you guys have not done that, then I would suggest you to, to please go and watch that chapter. You can watch that chapter on special as well, okay? Special are the free life classes. What are these? These are the free life classes, and of course you can always use my code, that is Kirti S Live. KIRTIS and live. You can always use this code if you want to watch the special sessions free. Like for the first time, you need to apply a code. So you can definitely apply this code. And if you are planning to take the plus subscription, okay, because only on the plus platform we cover 100% of the syllabus along with your sample papers, illustrations and everything. But this, by using this code, you will get additional 10% discount. What are you gonna get? You will get additional 10% discount, okay? And these days one mega offer is going on. It is nothing but a mega offer, okay? And what is the deal in that mega offer? That is, if you get the subscription for 12 months or above, means for a minimum of 12 months you need to get the subscription, and then you will get 2 months extension free. You will get 2 months extension free, okay? So basically you will get the subscription for 14 months in the 12 months of pricing. And moreover, like one more offer, one more deal is going on, that is, if you get the subscription for ISC class 11, you will get the subscription for ISC class 12 free. All right, so by using all these three offers, it's going to be really economical for you. And since your exams are very near, so it's better to, have a good mentorship, have a good guidance along with the preparations, so that everything will be very sorted. All right, everything will be very sorted. All right, so yeah, now let's look at this point which we have already discussed, that is, coordination compounds have specific colors, right? Therefore they find a common place in industries for intense colorations. Phthalocyanine is a class of coordination complexes that the dyes and pigment industries, means wherever the color is required, industries extensively use. They use it to impart specific colorations to the fabrics, right? कपड़ों को रंगने के लिए, to fabrics को color करने के लिए we use coordination compounds, okay? So like by telling you this general stuff, I just want you to know that coordination compounds are present everywhere. Even in the even in our body, there are many uh, coordination compounds such as hemoglobin. Yes, you are right, which is present in our blood, right? It is also a complex compound. If you talk about plants, जो plants में chlorophyll होता है, because of which photosynthesis occurs in plants, it is also a coordination compound. You can see here hemoglobin, chlorophyll, these are what? These are coordination compounds. And very essential vitamin, that is vitamin B12, it is also under the class of coordination compounds. All right, so like now you get to know that this is very important, right? Coordination compounds are present everywhere: hemoglobin, chlorophyll, vitamin B12. So these are like the general biological compounds which you definitely know. Okay, so like by studying this, by seeing this, you'll get to know that yes, these are present everywhere around us. So that is why like it becomes even more important to study about them. Okay. Next, now, coordination compounds are also used in the extraction of metals, okay, from their minerals, from their ores. When we extract metals, that is like metallurgy, and especially the coordination compounds are used in hydrometallurgy. Where are they used? They are used in hydrometallurgy. So you can see here that we apply the concept of coordination compounds in the extraction of metals from their ores too frequently these days. Extraction of nickel and cobalt involves uses a major use of these compounds. These metals are extracted by hydrometallurgical processes requiring a lot of complex ions. Okay. Yes, so it's working now again, right? Correct. Now it's working again. It stopped in the middle because I told you bar power cut ho raha hai. That's why. Okay. So yes, we apply the concept of coordination compounds in the extraction of metals from their ores too frequently these days, right? So extraction of nickel and cobalt uses a major use of these compounds. These metals are extracted by hydrometallurgical processes requiring a lot of complex ions. Okay. now we will be starting with the basic introduction. Okay. Now we will be starting with बहुत ही कॉम्प्लिकेशंस आ रहे हैं यार इसमें ना आज. टू मच कॉम्प्लिकेशंस फॉर नो रीज़न. Whenever I have a long session, I don't know why, like these things comes up daily. Now my Vacom word. Great. Hi Saif, how are you? Hi bacha. Okay, so now let's start with the coordination compounds का introduction. ठीक है, तो देखो, what do you know about it? You know already that the transition metals, what do you know? You know that the transition metals, we have already discussed about it as well. So you know already that the transition metals can form transition metals can form enormous number of compounds, right? They can form enormous number of compounds, right? And what we will learn about, let's see what we will learn about here. So you can see here that we will learn about. Number one, ways in which coordination compounds are formed. Number one is ways in which coordination compounds are formed. Ways in which these compounds are formed. Like, how are they formed, right? Very first thing that we will do today. Number two, how to name those compounds. इनकी naming कैसे की जाए? How to name those compounds, right? How to do naming of coordination compounds, that we will discuss. And number three, modern theories of bonding. Number three is modern theories of bonding to explain diversity. To explain diversity. ठीक है? These are the three basic things that we cover in this chapter, okay? Right. They form enormous number of coordination compounds, okay? And we have already done that they are colored as well, okay? So yes, now we will start the chapter from the very basics. So the very first thing is simple salt. What is this? Simple salt. So how are simple salts formed? See, if I take simply one acid and mix it with base, acid base reaction, ठीक है? तो क्या होता है? What is formed? Salt plus water is formed, right? You know already that salt plus water is formed. Let's take a proper example. If I tell you HCl plus base हमने ले लिया sodium hydroxide NaOH, and this will be again the neutralization reaction. So the salt which will be formed, it will be NaCl plus H2O, right? This will be the simple salt. Here NaCl is the simple salt. Now, how do you define simple salt? If I tell you that you have a beaker here, ठीक है? और इस beaker में पानी है. इस beaker में क्या है? पानी है. ठीक है? It has water. If you put this NaCl into this water, तो क्या होगा? Can anybody tell me? If you put NaCl in water, then what will happen? You will say that, ma'am, NaCl will be dissociated into its ions, right? So what will you have? Na positive aqueous plus Cl negative aqueous, right? Correct है? Na positive और Cl negative बन जाएगा. सही है? Sodium cation and chloride ion, these will be formed, right? So it gets dissociated into its individual components, right? Na positive और Cl negative में break हो जाते हैं आपके simple salts. When you dissolve them in water, they simply get dissociated into its ions, right? Now when what was I telling you? Yeah, so when you take this water and test for Na positive ions, so your test will come out to be positive, that yes, it contains Na positive ions. So we have done simple salts. The next thing which we need to do, these are addition compounds. What are these? These are addition compounds. अब addition compounds के बारे में I would say very interesting thing. You know what is very interesting thing about addition compounds? Two already stable compounds join together to form a third compound, okay, to form a new compound. Now the question which arises in case of this addition compounds, that is why to already when two compounds are stable, okay, then why are they joining together to give a new compound when they are already stable? So this was the question, ठीक है? So addition compounds में क्या होता है बच्चे? When जो already जो stable है compounds, they join together. So you can say regarding the addition compounds that these are formed, you can say that these are formed when stoichiometric amounts of two or more stable compounds. These are formed when stoichiometric amounts of two or more stable compounds join together. When two or more stable compounds join together. ठीक है? So these are what? These are your addition compounds. Now your addition compounds are of two types, okay? Your addition compounds now are of two types, okay? Number one is double salt. These are what? These are double salts. And secondly, we have complex compounds. You can say complex or coordination compounds, ठीक है? One and the same thing, complex or coordination compounds, ठीक है? So your addition compounds are of two types, double salts and complex compounds. You can see here, here it is written as well that these are formed when stoichiometric amounts of two or more stable compounds join together, okay? So you can see here that addition compounds are of two types, double salts and complex compounds, okay? Now let's talk about double salts. First we will be talking about double salts, all right? So yeah, what is the deal with double salts? So you can see that those which lose their identity in the solution, means when you mix a double salt in water, then they get completely dissociated into its individual ions. ठीक है? Yes, Seth. Seth, like, what about the schools? Like, do you have online classes, offline classes? What is happening? What is happening, bacha? So yeah, we are talking about double salts. Let's complete this discussion. So yes, as I told you that those which lose their identity in the solution, means if you have, let me give you example, okay? Let me give you examples. You know what? Two stable compounds and those stable compounds KCl and MgCl2, potassium chloride and magnesium chloride. KCl and MgCl2, you know already that these are very stable compounds, right? Even then, these two compounds join together to give a new compound. For example, let me give you one example. It is like the compound which is formed, it is KCl MgCl2, KCl MgCl2 dot 6H2. This is the compound, all right? And if you dissolve it in water, if you dissolve this in water, what are you gonna get? You will get all the individual ions. सभी के सभी individual ions में dissociate हो जाएगा. You can see K positive plus Cl negative plus Mg2 positive. So you can see that it gets dissociated into all of its individual ions, okay? Now if you test the solution individually for these ions, K positive, Cl negative, Mg2 positive. So your test will come out to be positive, that yes, this individual ion is present in the solution. Okay, so this is a very important point. You can see here, those which lose their identity in the solution, they are called as double salts. They exist as such in crystalline state. Okay, when dissolved in water, these dissociate into ions of their individual components. We अभी हमने देखा K positive, Cl negative, Mg2 positive सब में dissociate हो गया. And in aqueous solution, they give the test for all their constituent ions. I told you, right? From 10 a.m. my classes get started. Online na, Saif, online classes bacha. Let me share the session again on Telegram. Done. ठीक है? Okay. ठीक है सैफ, that's great. Share the session with your friends as well, ठीक है, so that they will also be here. So this is the deal with double salts. Okay, now let's one more thing about double salts. You can see that these are the addition molecular compounds which are stable in solid state. Solid state mein they are stable but dissociate into constituent ions in the solution. The example is Mohr salt. Another example is Mohr salt. Okay, and the example which was above, it was nothing but your alum. Okay, so you can see here FeSO4.NH4 whole twice SO4.6H2O. So when you dissolve it in water, when you dissolve this in water, so it gets dissociated into all of its individual ions, Fe2 positive, NH4 positive and SO4 2 negative. Okay, so this is the deal with double salts. I believe इसमें कोई doubt नहीं होगा. Great, Seth. Share it with your friends as well. It would be perfect. Okay, yeah. Now let's talk about complex or coordination compounds, right? So in a complex or coordination compound, even if you dissolve it in water, when you dissolve the coordination compound in water, I'm not saying that it does not get dissociated. No. It gets dissociated, but not into the individual component ions. Okay, are you getting the difference? It doesn't get dissociated into the individual constituent ions. Okay, I can say that if I give you this example, something like this, I'll let you know like why are coordination compounds written like this, and we'll do everything. Right now just understand K4FeCN whole 6. Okay, this is your coordination compound. That's how you write them. Okay, if you dissolve them in water, so what are you gonna get? You will be getting 4 K positive ions. Okay, K potassium positive ions आपको मिलेगा. ठीक है, इसके साथ साथ the another ion which you will get, it will be a complex ion. Complex या coordination compounds आपको कैसे ion देंगे? It will give you complex ions. Okay, so your complex ion, this is something complex part, right? So this is your complex ion, FeCN whole 6 और इसके ऊपर 4 negative charge, right? You can see here like why here 4 negative charge, because you can see that the whole compound has 0 charge, right? The whole compound is neutral. So if here we have 4 positive charge, तो इसको balance करने के लिए we have to have 4 negative charge here. Okay, so that is how your coordination compound gets dissociated. Okay, not into just the individual component ions, but it gives you complex ions. Okay, it gives you complex ions. I believe that there is no doubt till now. Okay, so we can say that they retain their identity in the solution. Now, what is meant by that they retain their identity in the solution? It means, like, when you see now this dissociated, this your compound dissociated into 4k positive and this complex ion, right? Now when you test for individual ions, if you test for Fe2 positive, if you test for Cn negative, your test will come out to be negative, that this that these ions are not present in the solution. You will get this test, मतलब the test will be negative. But in the case of double salts, आपको क्या मिल रहा था? You were getting that इंडिविजुअल आयंस का जो टेस्ट था वो पॉजिटिव आ रहा था, राइट गाइस? आई होप दैट यू अंडरस्टूड द डिफरेंस बिटवीन कॉम्प्लेक्स कंपाउंड्स एंड ऑल क्लियर? दैट्स ग्रेट सेफ. ठीक है, लेट मी नो इफ यू हैव अ डाउट, देन वील गेट इट सॉर्टेड. ठीक है, सो नाउ यू कैन सी दिस इज अ वेरी इंपॉर्टेंट, आई वुड से theoretical question which sometimes comes into your examination. Okay, what are addition compounds, and differentiate between double salts and coordination compounds. Sometimes this is your 3 marker question. Okay, so here you can see the exact differences between double salt and coordination compounds, right? You can see here about double salt that these exist only in solid state and dissociate into constituent species in their solution. Okay, and about coordination compounds, so they retain their identity, or you can say that they do not lose their identity in solid as well as solution state, or you can say in the aqueous state. Okay, second, they lose their identity in dissolved state. Coordination compounds, they don't lose their identity in the dissolved state. Third, their properties are essentially the same as those of constituent species, but यहाँ पे coordination compounds की जो properties होती हैं, they are different from their constituent ions. You can see here, for example, K4FeCN6, the same thing we discussed, does not show the test for Fe2 positive and Cn negative ions. Okay, in double salts, the metal atom or ion exhibit normal valency, whereas in case of coordination compounds, the number negative ions or molecules surrounding the central metal atom is beyond its normal valency. I'll make you understand about this point later on. Okay? Cool. Now let's move ahead, and the next thing which we will be discussing, it will be Werner's theory. It's going to be Werner's theory. Okay, so yes, let's see what is the case with Werner's theory. Now you can see here that this is a theory of 1893, right? This is a theory of 1893, correct? So the question is, why is this theory important, right? Why even this theory is important? So Werner uncle was the very first person, who tried to, like, who took an attempt to, explain the bonding of coordination complexes and how it works. Okay, so he was the very first person. Like, there were various questions in everyone's mind, that in addition compounds, why like two stable compounds are joining together to give several new compounds, right? And why are their structures so different? Okay, so these were the question, and Werner uncle was the very first person who decided to, it was the first attempt to explain the bonding of coordination complexes. Okay, and in order to answer these questions, so Werner theory के according, Werner uncle ने बोला that metal exhibits two types of valencies. Okay, metal exhibits two types of valencies. Now this type of concept we have never done till now, right? So according to Werner uncle, primary valency and secondary valencies. There were two things, okay? Primary valency and secondary valency. So primary valencies को simply जो oxidation number होता है, we have done this in redox reactions, right? I have told you very yes बच्चे, sure Saif, you can start. Okay, so yeah, where were we? Yeah, you can watch the recorded session if you have any doubt, like you can watch it later on. Okay, and keep sharing the session in your school groups and class groups as well. Okay, so that it will be, pretty good, that everyone will be knowing that yes, this category has been launched. Okay, cool. So yes, according to Werner's theory, we have two types of valencies, primary valency and secondary valency. Okay? So simply the oxidation number was called as, बच्चे है स्पेशल क्लास है 6:30 पे भी है और 8 PM पे भी है, 6:30 PM and 8 PM as well. ठीक है? Yes sir. ठीक है? Plus class 4 to 5, then 6:30 to 7:30 and then 8 to 9. ठीक है? This is the schedule. Alright? So yeah, the primary valencies correspond to the oxidation number, you can see. And देखो, जो primary valency होती है, it is oxidation number, right? And it is only satisfied by anions. Yes बच्चे, ठीक है? And these are only satisfied by the anions. Okay, these are ionizable and these are non-directional in nature. Okay, whereas your secondary valency is simply coordination number. Now coordination number is how many ligands are basically attached. That's nothing but your I'll be back, like give me 10 minutes. ठीक है? So secondary valencies correspond to the coordination number of the metal atom and are satisfied by ligands, right? These are non-ionizable and directional. These are directional, okay? So hence geometry is decided by these valencies. Okay, we will discuss about them. Now, what about like Werner's theory? Could Werner theory explain, like was it able to explain? So yes, according to the postulates of Werner's theory, it was actually based on, you can say, experimental evidence rather than theoretical, and he was quite successful to explain the bonding of the coordination compounds. But there were some drawbacks as well. You can see that these were the drawbacks of the Werner's theory. Okay? So it could not explain that why only certain elements form coordination compounds. Why not all the elements, right? Secondly, it does not explain why the bonds in coordination compounds have directional properties, right? Or like why the coordination compounds are colored, the magnetic properties and the optical properties. This was not explained by Werner's theory. Okay, so if you're here, that's great. Okay, so yeah, this is the case. Now next we have is some important terms in which we will discuss what is like a central metal atom or ion and everything. We'll discuss everything. Okay, that's what we are gonna do in the like after 10 minutes break. Let me have my breakfast in 10 minutes and then we will start the class again. So you have 10 minutes break. We have 10 minutes break. Okay, Oops, 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 oops. Okay, so I just realized that I was mute in the middle. So I have to tell you again about where we left. Where we left? We left at here, right? So from here I need to start again because I was mute, okay? But no issues, we will do it again. It was very simple, no issues. So yes, you can see here that K4 FeCN6, if you look at it, so it gets dissociated as 4K positive and FeCN whole 6 4 negative, right? So the ion which is present outside this square bracket, it is called as, now let me check please. Great. So yeah, the ion which is present, the atom or ion which is present outside the square bracket, you call it as, you you call it as spectator ion. You call it as spectator ion or counter ion. Okay, what do you call it? You call it as spectator ion or counter ion. All right, now let's jump in the square bracket, the complex wala part. So this is called as coordination sphere. It is called as coordination sphere या coordination entity या फिर इसको complex entity भी आप बोल सकते हो. ठीक है, क्या है? This is the complex wala part. So this is nothing but your complex entity. All right, this is nothing but your complex entity. Okay, now in the square bracket, something which is written in the normal brackets, these are ligands. Now ligands are, I told you already that ligands are nothing but electron donating species. These are electron donating species. Okay, these are electron donating species. So let me tell you, if here is a metal atom, okay, and suppose like here in this way we have ligands attached. Here ligand, 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 ligand. Okay, in this way the ligands are attached. All right, so now both of the electrons, in case of a coordination bond, I am telling you like what is a coordination bond, coordinate bond आप कह सकते हो. What is a coordinate bond? So see, in a coordinate bond, both of the electrons, right, you need two electrons to form a bond. So both of the electrons are donated by ligand to the central metal atom or ion. ठीक है, both of the ligands are like both of the electrons are donated by the ligands to the central metal atom or ion. Okay, so this is a coordinate bond and you show by this arrow, you mean that ligand has donated both the electrons to the central metal atom or ion. Okay, so yeah, as I told you, like something which is enclosed in the normal brackets, they are your ligands. और जो normal like something which is not in the bracket, it is your central metal atom. ये क्या होता है? It is your central metal atom or ion. It can be called as atom if it is neutral. It will be called as ion if it is charged, right? Very simple. So yes, this is the case. Cool है? This is the case. All right. So yeah, now you can see the same definition of the terms that we just understood. So you can see here that complex ion or complex entity, it is what? It is an electrically charged species in which central metal atom or ion is surrounded by number of ions or neutral molecule. So our complex entity can be cationic or it can be anionic, right? Cationic, obviously when it has a positive charge, so it will be called as cationic complex entity. एंड इफ द कॉम्प्लेक्स एंटिटी के ऊपर, मतलब जो स्क्वायर ब्रैकेट्स वाला पार्ट है, अगर उसके ऊपर नेगेटिव चार्ज है, सो इट विल बी कॉल्ड एज एनायनिक कॉम्प्लेक्स एंटिटी, राइट? You can see the examples here. Now, central atom or ion. So you can see here the atom or ion to which a fixed number of ions or groups are bound. So these are what? These are ligand. जो groups bound होते हैं उनको आप क्या बोलते हो? Ligand बोलते हो, right? It is also referred to as Lewis acid because it accepts electron. Why Lewis acid? Because it accepts electron, right? Electron को accept करता है, correct है? So you can see here, then ligands, we already discussed that these are the electron donating species. Coordination number. Now what is coordination number? See, how many coordinate bonds are formed by the central metal atom with the ligands, ठीक है? If I give you the same example, say this one. So here you can see how many bonds are formed by the central metal atom with the ligands. So it is 1, 2, 3, 4, 5, 6. So the coordination number here is 6, okay? And obviously you can calculate the coordination number generally by just simply seeing what is the number here, ठीक है? So it shows coordination number here. You can see na 6 is written over here, right? You can see that 6 is written over here. So this 6 is what? This 6 is coordination number, ठीक है? The number of coordinate bonds that metal can form with the ligands, ठीक है? It is defined as the number of coordinate bonds formed by central metal atom with the ligands, alright? Now, the next thing is coordination sphere. What is next thing? It is coordination sphere, okay? So yes, the central ion and the ligands attached to it are enclosed in square bracket, right? Coordination sphere, जो आपका पूरा मामला square bracket के अंदर होता है, it is nothing but your coordination sphere. The ionizable group, you can say that, the ionizable group written outside the bracket is known as counter ions. What do you call it? You call it as counter ion, okay? Now, the next thing, coordination polyhedron, like the spatial arrangement, like how the ligands are arranged in the space, okay? कि वो कैसे arranged हैं. It is called as coordination polyhedron, ठीक है? The spatial arrangement, like how the ligands are arranged in the space, it is called as coordination polyhedron, ठीक है? ठीक है? 11:30, right? So yeah, next thing, some important terms. So the next thing is oxidation number. Oxidation number, I have told you how to calculate, right? So you can see here, the charge of the complex, if all the ligands are removed along with the electron pairs that are shared with the central atom, just give me a moment, guys. ठीक है? So yeah, we were at oxidation number. I have already told you like how to calculate oxidation number, right? Next we have is homoleptic complex and heteroleptic complexes. So homoleptic complexes वो होते हैं जिनमें सिर्फ और सिर्फ एक तरीके के ligands present होते हैं. Alright, homoleptic complexes are the ones in which only one type of ligand is present. So you can see here all the ligands which are present here, those are NH3, right? These are NH3. And what about heteroleptic complexes? So complexes in which the different, like more than one kind of ligand is present, it will be called as heteroleptic complex. What will you call it? You will call it as heteroleptic complex. Okay? So complexes in which metal atom or ion is linked to more than one kind of donor atoms are called as heteroleptic complexes. Example, you can see here. One is NH3. I am not taking the name of the, what do you call it? The ligand, right? Because like I'll let you know how to name them when we will just move to the naming after this part. Okay? Right. So ligand is electron donating species bound to the central atom in the coordination entity. Okay. Now, we will discuss about what is denticity. Okay. What is denticity? So denticity is that if you have one ligand, okay. Denticity का क्या मतलब होता है? If you have one ligand, then how many coordinate bonds that one ligand can form? वो उस ligand की denticity होगी. If I tell you that this is my ligand, okay, this is my ligand and this is my central metal atom or ion, ठीक है? If this ligand can form only on one coordinate bond with the central metal atom, okay, only on one this, ठीक है, only on one, ठीक है. तो it is on 13th, right? ठीक. So this will be, तो यहाँ पे इसकी denticity, the denticity of the ligand here is how much? It is 1. Denticity equal to 1 for this ligand. Now suppose if your ligand is something like this, ठीक है? If say this is your ligand, ठीक है? Something like this. If this is your ligand, this is your central metal atom. If your ligand can form two coordinate bonds with the central metal atom, तो यहाँ पे इसकी डेंटिसिटी क्या हो जाएगी? So the density is 2 here because it can form two coordinate bonds with the central metal atom. Okay. So yeah, if we talk about ligands, so we know that these are the electron donating species. जो ligands हैं वो अपने electron किसको देते हैं? Central metal atom को या फिर ion को, right? So yeah, if we talk about ligands, so these can be charged in the sense they can be negatively charged, as in if I have a negative charge means I have like more number of electrons, so I can donate it, right? So of course negatively charged, neutral, मतलब न्यूट्रल वाले इलेक्ट्रॉन, न्यूट्रल वाले कंपाउंड्स में, न्यूट्रल वाले ligands में what will be the case? They would have like extra lone pair, right? तो उस lone pair को donate कर दिया and ligand ने अपने bond बना लिया metal के साथ. But पॉजिटिव भी हो सकते हैं ligands. Now you will be like, मैम अगर उसके ऊपर खुद पॉजिटिव चार्ज है, means it is electron deficient, then how can it, donate electrons? So but I'll let you know how this can happen. Okay, so ligands can be charged or neutral, and ligands are of the following type. So these can be unidentate. Now what are unidentate बच्चे? जिनकी denticity 1 होती है. Unidentate ligand कौन से होंगे? Those which have denticity equal to 1, जिनकी one denticity है, they are nothing but unidentate ligands. Okay, so yes, it is a ligand which has one donor site, that is the ligand bound to a metal ion through single donor site, right? Through a single donor site. Unidentate को आप monodentate भी बोलते हो. Unidentate is also called as monodentate. Okay, so yes, Monodentate, it is a ligand which has one donor site. Examples H2O, NH3. You know, ऑक्सीजन के पास यहाँ 2 लोन पेयर है, NH3 के ऊपर यहाँ पे नाइट्रोजन के पास एक लोन पेयर है. So these are इनकी डेंटिसिटी इज 1 because they can form only one coordinate bond with the central metal atom or ion. Okay, then you have didentate और bidentate भी आप इसको बोलते हो. डाइडेंटेट या बाइडेंटेट लीगेंड विच हैव 2 डोनर साइट्स. तो यहाँ पे बच्चे डेंटिसिटी कितनी होगी? द डेंटिसिटी विल बी इक्वल टू 2, राइट? 2 डेंटिसिटी होगी. यू कैन सी हियर द ऑक्सिलेट आयन, it is what? It is bidentate, or you can say didentate, right? Oxalate ion, COO negative, COO negative. Then we have ethylene diamine, CH2NH2, CH2NH2. You can see here that this is nothing but, it is nothing but your डेंटिसिटी 2 वाला लीगेंड. ठीक है. देन यू हैव पॉलीडेंटेट लीगेंड्स, मतलब विच कैन फॉर्म लाइक विच हैव सेवरल डोनर साइट्स. ठीक है, जिसके डेंटिसिटी 2 से ज़्यादा है. लाइक ओनली ऑन वन लीगेंड कैन फॉर्म मोर दैन 2 coordinate bonds with the central atom or ion. In that case you will simply call it as polydentate ligand. The very important example is EDTA. The very important example is EDTA. ठीक है, that is ethylene diamine tetraacetate. What is the full form? It is ethylene diamine tetraacetate. Ethylene diamine tetraacetate. This is the name. I just closed my this. ठीक है. So yeah, this is ethylene diamine tetraacetate and this is a polydentate ligand. Now then, what about ambidentate ligands by? Ambidentate ligands, just like ambidentate nucleophiles you have done, right? Means which can form the coordinate bonds. Like if I talk about NO2 negative, okay, this is NO2 negative, this is NO2 negative, right? So if I talk about NO2 negative, so it can form bond with like from both the sides. नाइट्रोजन साइड से भी बना सकता है और ऑक्सीजन साइड से भी बना सकता है. ठीक है. So this is your ambidentate ligand. Now let's learn how to name ligands. ठीक है, यहाँ से we are starting with the naming of ligands. Naming of ligands. ठीक है. So first of all, the thing is you should know how to name ligands, right? The thing is how to name ligands, and we were talking about this NO2 negative. So you know already that the structure is something like this, right? N, एक यहाँ पे coordination bond, एक double bond. ठीक है. So if the coordinate bond is formed through nitrogen side, in that case it is called as nitrito O. And if the bond is formed through oxygen side, ठीक है, यहाँ से निकाल देते हैं bond. If the bond is formed through oxygen side, in that case it is called as nitrito O. Oops, sorry. If the bond is formed through nitrogen side, it will be nitrito N. And if the bond is formed through oxygen side, then it will be nitrito O. ठीक है. Now let's discuss how to name ligands. Okay, now we'll discuss how to name ligands. So you can see here anionic ligand and ligand name. ठीक है. So if your ligand is anionic, मतलब it has a negative charge. For example, it is Br negative. That is your bromide ion. Okay. So if it is present as a ligand, you will call it as bromo. What will you call it? You will call it as bromo. Carbonate, CO3 2 negative. You can see here CO3 2 negative. If this is carbonate, you will name, if it is present as a ligand in the central metal atom, in the coordination compound, you will call it as carbonato. आप इसको क्या बोलोगे? Carbonato. Chloride, Cl negative, you will call it as chloro. Cyanide, Cn negative, you will call it as cyno. Fluoride, F negative, you will call it as fluoro. Glycinate, Gly negative, you will call it as glycinato. Hydroxide, OH negative, you will call it as hydroxo. C2O4 negative, जो अभी हमने देखा था ना, oxalate ion, COO negative, COO negative, ये. This is oxalato. Oxalate ion ko, if it is present as a ligand, what will you call it? You will call it as oxalato, right? What will you call it? You will call it as oxalato. Okay. Thiocyanate, SCN negative. You can see that अगर ligand donor atom is S, तो आप उसको क्या बोलोगे? Thiocyanato. एंड अगर जो बॉन्ड है वो नाइट्रोजन के साइड से बन रहा है, सो यू विल कॉल इट एज आइसोथायोसाइनेटो, SCN नेगेटिव. ठीक है, कूल. देन द नेक्स्ट थिंग विच कम्स इज लाइक न्यूट्रल लीगेंड. अभी तक जो हमने किए, दीज वर द एनायनिक लीगेंड्स. नाउ वी हैव हियर न्यूट्रल लीगेंड्स. व्हाट डू वी हैव? दीज आर द न्यूट्रल लीगेंड्स, राइट? सो अमोनिया, NH3, आप इसको क्या बोलोगे? यू विल कॉल इट एज अमीन. यू विल कॉल इट एज अमीन. वाटर, एक्वा, व्हाट विल यू कॉल इट एज? एक्वा. कार्बन मोनोक्साइड, दिस इज आवर कार्बोनिल ग्रुप. एंड इथाइलिन डायमीन, EN, जो भी हमने पीछे डिस्कस किया था, इट विल रिमेन एज इट इज इथाइलिन डायमीन. ठीक है, इट इज नथिंग बट इथाइलिन डायमीन. ओके, so this is the case. All right, it is called as ethylene diamine. Take a moment and you need to learn them. We need to learn them, okay? Because one or two questions will be definitely there in which you have to name the compounds, right? In which you have to name the compounds. Okay, cool. Let's move ahead. Now you can see that something which we have already done, unidentate, bidentate, polydentate ligands. ठीक है, H2O, NH3, ammonia, fluoride ion, chloride ion, cyanide ion, thiocyanate, hydroxide, nitride, these are all unidentate. मतलब इनकी denticity कितनी है? सभी ligands की denticity is 1. Means they can form only on one coordinate bond with the central metal atom or ion, right? If I talk to you about bidentate, तो इनकी denticity कितनी है बच्चे? Denticity will be equal to 2. कितनी denticity आएगी इनकी? 2 denticity. Means they can form 2 coordinate bonds with the central atom. You can see here. इधर एक नाइट्रोजन प्रेजेंट है, इधर एक नाइट्रोजन प्रेजेंट है, तो यहाँ से कोऑर्डिनेट बॉन्ड, यहाँ से कोऑर्डिनेट बॉन्ड विद द सेंट्रल मेटल एटम. सिमिलरली एक कोऑर्डिनेट बॉन्ड फ्रॉम दिस ऑक्सीजन, एक कोऑर्डिनेट बॉन्ड फ्रॉम दिस ऑक्सीजन. ठीक है, सो दैट्स हाउ वन लीगेंड कैन फॉर्म 2 coordinate bonds with the central metal atom or ion. Polydentate, you can see here, one from this nitrogen, one from this nitrogen, one bond from this nitrogen, right? Similarly here and everywhere you can see it can form even 5 ethylene diamine tetraacetate. It can form 1, 2, 3, 4, 5, 6 coordinate bonds. Only on this one ligand, akela, alone, it can form 6 coordinate bonds with the central metal atom. ठीक है, it can form 6 coordinate bonds with the central metal atom. ठीक है, so yeah, this is the case. Okay, now let me tell you, just give me a moment. Let me just find something for you. Okay, चलो let me tell you what we have new for you. Okay, so we have SQPs sessions. So these are nothing but, these are very important sessions in which we discuss basically sample papers, specimen question paper discussion. Let me correct the spelling. It is specimen question papers. ठीक है? Specimen question papers. ठीक है? In which we discuss the specimen question papers. Means basically this is a session of sample paper solving sessions. These are sample paper solving sessions. ठीक है? Sample paper solving sessions. Cool. So you can see here, let's crack SQPs, and my SQP session is today. Yes. So guys, you can download Unacademy app, and this is like, it will be a free session. Okay, this is under special classes, and special classes are free for everyone. You just need to enter the code. Okay, and my code is Kirti S Live. My code is Kirti S Live. This is my code. Okay, so like you can use this code for, you can use this code for can use this code for entering into the free live class, and you can use the same code if you want to get 10% additional off. 10% additional off on plus subscriptions. ठीक है? On plus subscription. ठीक है? Moreover, we have like AC or race sessions, and these are the dual sessions. Okay, these are dual sessions. Okay, these are dual sessions. You can see me and Sanam sir would come together on the like same special platform, and we will discuss like some tips and tricks with you. Cool. And you know already, whether on plus, whether on special or YouTube, we have arranged one shot sessions for you, and after these sessions we discuss I would say previous year questions and MCQ session, and polls are there, right? So you can like take part in this one shot revision. Okay, apart from it, like one mega offer is here, and that mega offer is, if you get the subscription for, if you get the subscription for a minimum of 12 months, then you will get 2 months extra, 2 months extension free. Then you will get 2 months extension free. All right, cool guys? Yes. Before starting with this, I would like to start with the with naming, right? So yes, let's start with naming. I have told you about this. Now let's start with the naming. Okay, now let's just start with the naming. Just a moment. Yes, let's talk about name of the metal atom. Let's talk about name of metal atom or ion. Name of metal atom or ion. Okay, so you can see here, if your metal is let's take a simple metal. If your metal is chromium, okay, that's chromium, right? If your metal is chromium, if the central metal atom is present in the cationic part, if it is present in, yahin pe likh lete hain, in fact, if it is present in the cationic part, then the name remains the same. But if the central metal atom is present in the anionic part, then in that case आप उसके लास्ट में ATE लगा दोगे. What will you add? You'll add ATE. So chromium will become chromate. Chromium will become chromate. Okay. Similarly, platinum अगर है, if it is present in the cationic part, the name will remain as it is, platinum, right? But if it is present in the anionic part, it will become platinate. It will become platinate. Similarly, if you have zinc, so if it is present in the cationic part, it will remain as it is, and if it is present in the anionic part, you will call it as zincate. Okay? So you will basically add ATE in the end if the central atom is present in the anionic part. All right? Cool, guys? Now let's move ahead. Let's start with the naming now. Okay, let's start with the naming now. So if I give you the compound as K3, okay, let me tell you the rules first now. Let me tell you the rules first. Although I have already told you in the previous sessions, but yeah. Always आप सबसे पहले क्या करोगे? Sorry. Number 1. Always write cation name first. Cation first. Cation first. Followed by anion. ठीक है? सबसे पहले आप किसका नाम रखोगे? केटायन का नाम रखोगे. सपोज योर कंपाउंड इज K4FeCN6. ठीक है, दिस इज द कंपाउंड. सो यू कैन सी हियर दैट दिस इज द केटायन, राइट, एंड दिस इज एनायन. So you will always write the name of the cation first. If your compound is like this, say CONH3(6)Cl3, ठीक है. So you can see at this time this is cation, right? So you will name it first and in the end you will name the anion, ठीक है. So you will always write the name of the cation first, ठीक है. You will always write the name of the cation first, okay. Number 2, you can see that for the coordination sphere, central atom first. पहले आप किसकी नेमिंग करोगे कोऑर्डिनेशन स्फीयर में? इन दिस स्क्वायर ब्रैकेट you will first name the central atom first and then ligands in alphabetical order. ठीक है. ligands का नाम आप कैसे लिखोगे? alphabetical order में लिखोगे, ठीक है. cool. this is the first rule, ठीक है. Number 3, you have to use the prefix. Use prefix di, tri, tetra. In this case, di, tri, tetra, penta, hexa. ठीक है, before the name of the ligand कि कितने ligands present है. Suppose you have NH3 whole thrice. This is the ligand. So you will write it as triamine. कैसे हम इसे लिखेंगे? We will write it as triamine. ठीक है. If we have H2O4, so how will we write it? We will write it as tetra aqua. That's how we will write it, tetra aqua. ठीक है. So that's how you do. ठीक है. अगर ligand के नाम में ही already bi, di, tetra ऐसे लगा हुआ है, in that case you will use different prefixes such as bis, tris, tetrakis, pentakis in this way. ठीक है, जैसे कि इथाइलिन डाइअमीन. ठीक है, इफ इट इज EN होल ट्वाइस. ठीक है, आपके पास 2 इथाइलिन डाइअमीन है. सो हाउ विल यू राइट इट? you will write it as bis, फिर ब्रैकेट में इथाइलिन डायमीन, इथाइलिन diamine. In this way you will write. Okay, so these are basically the rules. Now simply let's get started with the naming. Okay, and at the end of the central metal atom you will always write the oxidation number in the, you will write oxidation number of central metal atom in Roman numerals. ठीक है, in Roman numerals. ठीक है, so yes, let's get started. ठीक है, with the naming. If I give you, say, the compound K3FeCN whole 6, K3FeCN whole 6. ठीक है, K3FeCN whole 6. ठीक है, so how will you write it? So as I've already told you to write the name of the cation first. So this is cation, this is what? Potassium, right? So write potassium. Next, now we will write the name of the ligand, right? We will write the name of the ligand first, and that too in alphabetical order. So here we have CN whole 6, so it will be potassium hexacyano, right? Potassium hexacyano, and here we have Fe. So you will write ferrate because it is present in the negative, in the anionic part, right? So hexacyanoferrate. And what is the oxidation number here? You can see CN का क्या होएगा बच्चे? So the here it will come out to be +3, right? Correct. So this is the oxidation number. That's how you name coordination compounds. ठीक है, this is how you name coordination compounds. Okay, cool है guys? I believe that there is no doubt till now. All right, let's do some more examples. If I give you Cr H2O whole 4 Cl2 Cl, if this is the compound, how will you write it? ठीक है, how will you write it? So we will name the cation first, और cation है अब की बार हमारा complex. ठीक है, so how do we name the complex part? We first name the ligands in the alphabetical order. So we have tetraaqua, right? 4 aqua present है. Tetraaqua dichloro, right? Tetraaqua dichloro, you can see dichloro. Then chromium किस पार्ट में प्रेजेंट है? पॉजिटिव, तो एज इट इज ही रहेगा बच्चे क्रोमियम. ठीक है, डाइक्लोरो chromium. What is the oxidation number of chromium here? Water is neutral, Cl2. देखो क्लोरीन -3, so in order to balance it, chromium का कितना होगा? +3. Chromium third chloride. So this is the name of the compound. Let's look at the next. ठीक है, अगला देखते हैं. If I give you CrNH3 whole thrice, H2O whole thrice, Cl3. This is the example. तो इसका नाम क्या होगा बच्चे? Let's name it. So this is the cation part. The complex part is it is cationic, so we will name the cation first. And in the, पता है मेरे को ऐसे लग रहा है, you will name the ligand first. ligands का आप नाम रखोगे in the alphabetical order, ठीक है? So yes, how will you name it? You can say triamine. How will you start from here? Triamine, right? Triamine and triaqua, right? Triamine, triaqua. You have named the another ligand, and now you will name the name of this central metal atom. So it's chromium, right? Chromium third, and end में again chloride, ठीक है? Chromium third chloride. This is the deal, ठीक है? Now let's quickly go back and let's look at isomerism, ठीक है? So you can see here isomerism in coordination compounds. So coordination compounds, structural में there are linkage and coordination isomerism in front of you, ठीक है? You can see here. हाँ, so you can see बच्चे in linkage isomerism, it is the type of isomerism is shown by coordination compounds having ambidentate ligands. Which type of ligands you can see here? Here it is present NO2 and here as ONO. मतलब एक तरफ जो बॉन्ड है वो नाइट्रोजन के साइड से बन रहा है और दूसरी साइड में ऑक्सीजन के साइड से बन रहा है, ठीक है? Then we have coordination isomerism. Arises from the interchange of ligands between cationic and anionic complexes. You can see here CrNH3 whole 6 COCN whole 6. और देखो यहाँ पे आप देखोगे there is an interchange of ligands, right? यहाँ पे CO के साथ NH3 whole 6 है, यहाँ पे CN6 जो है वो क्रोमियम के साथ है, यहाँ पे CO के साथ था, ठीक है? Geometrical isomerism cis trans आपको पता ही है, right? And the basic thing, this we will discuss only in the plus sessions, ठीक है? This thing we will discuss only in the plus sessions, okay? So you can see here that let's look at stereoisomers have the same chemical formula and chemical bonds, but they have different spatial arrangement, right? कि जो ligands का arrangement होता है वो different होता है. So there are basically two types of stereoisomers, geometrical isomers. So we can see geometrical isomers are of two types, cis and trans. ये तो अपने को पता है cis and trans. We have already done this in class 11. This isomerism is common in complexes with coordination number 4 and 6, right? Next thing is that tetrahedral complexes जो होते हैं they do not show geometrical isomerism. Cis trans isomerism they don't show. But the square planar complexes having formula mx2l2, m is the central metal atom और जो x और l हैं these are ligands. You can say जो m है this is the central metal atom and x and l these are ligands. और कैसे ligands है बच्चे ये? जिनकी जो denticity है वो 1 है. These are unidentate ligands, alright? So yes, the two X ligands may be arranged adjacent to each other in a cis isomer or opposite to each other in the trans isomer. So here you can see that chlorine chlorine or you can say NH3 NH3 जब एक दूसरे के साथ में है, ठीक है? They are adjacent to each other. In this case, it is called as cis isomer, and if they are present at the opposite side, then they are called as trans isomer. तो इनके properties काफ़ी different होते हैं, ठीक है? Cisplatin, only cisplatin is used in cancer treatment. Is used in cancer treatment. ठीक है? It is used in cancer treatment. So square planar complexes are of the type MABXL, where A, B, X and L are unidentate ligands, and examples you can see here. Then we have optical isomers, बच्चे. So there are the complexes which have chiral structures, right? It arises when mirror images cannot be superimposed on one another. These mirror images are called enantiomers, and the two forms are called as dextro and levo, right? As I told you, we will discuss these in detail in the plus sessions, okay? Bonding and coordination compounds. So bache, the very first is which is written here, it is Werner's theory, which we have already done in the beginning of the session, right? When I told you that there are two kinds of valencies, primary and secondary, right? Primary valency, oxidation number, secondary valency, coordination number, okay? So Werner's theory, and as I told you that there are certain limitations to this theory, but Werner uncle was the very first person who tried to, who attempted to answer the questions regarding the coordination compounds, like why their properties are so different and everything. Okay, so this is what your Werner's theory is. Next is valence bond theory. You can see here. So it was proposed by L. Pauling. It was proposed by L. Pauling in 1930. And according to this theory, when a complex is formed, the metal atom or ion provides empty orbitals to the surrounding ligand so that bonds can be formed. Coordination number shows the number of such empty orbitals. Number of empty orbital is equal to the coordination number, and these empty orbitals are hybridized. Before participation in bonding, and the nature of hybridization depends on the nature of metal and on the nature of approaching ligand. Okay? Now we have some more importance and applications of the coordination compounds. As I always tell you, I love to tell you about the actual thing where your concept is used. Okay, so number one is that they are used in the qualitative and quantitative analysis in your chemistry labs. Okay, since like maybe because of COVID you have not done your chemistry and physics lab experiments, but trust me, they are very fun. And as I have told you earlier as well, if you guys have not performed those experiments in the lab, then go to YouTube and search those experiments, see them, and listen about them, so that you will get an idea like how things work, whether it's titration, salt analysis, whatever that is, you'll get an idea about it. Okay, so yeah, they are used in many qualitative and quantitative analysis by using coordination compound EDTA, ethylene diamine tetraacetate. Hardness of water can be determined, matlab ki how many, like which salts are present in water, so the hardness of water can be estimated when it is titrated with Na2EDTA. Okay, and purification of metals, and in the extraction of metals as well, coordination compounds are used. So you can see here that the purification of metals can be achieved through the formation of subsequent decomposition of their coordination compounds, right? They have great importance in the biological systems. So I have already told you not just like these things, but also your coordination compounds, as we discussed in the beginning, they are present in our biological system as well, such as in our blood. Hemoglobin is nothing but a coordination compound. Chlorophyll is nothing but a coordination compound. Vitamin B12 is nothing but a coordination compound. Okay, so these are all coordination compounds, and they have like a great importance in the biological systems as well. Okay, then in the industrial processes, in many chemical reactions, coordination compounds are often used as catalyst as well. Okay, catalysts are which enhance the activity of the reaction, right? That is your That's your catalyst, right? And in medicinal industries, chelating therapy, chelating, बच्चे chelating ligands नहीं करे ना हमने. Chelating ligands होते हैं जो ऐसे रिंग में ligands होते हैं. They are simply chelating ligands. Okay. So yes, that is it about your chapter. And as I have already told you, we have this SQP session, ठीक है? Ace your race session on the platform, so you can go and have it. And as I told you that we have a mega offer for you, that is, if you get the subscription for 12 months, you will get 2 months extension free. Apart from it, if you get the subscription for ISC class 11, you will get ISC class 12 subscription for free. Okay, so this is very important. And if you are in class 10, so you will get class 11 and 12, both the classes for free. So this is really something amazing, guys. And apart from it, you always know what is my code. That is Kirti S Live, KIRTIS and Live, Kirti S Live. This is my code, and you can avail 10% off by using this code. So by using all these three offers, this by by using all these three offers, it can be very amazing for you. It will be very economical for you. So I would suggest you to take it right now. And that is it for the day. Okay, Unacademy, let's crack it. So that is it for the day, guys. I'll see you in the next session. Okay, if you have any doubts, any query, you can join the Telegram group, which is given in the description box. Okay, so that you will get all the notifications and all the updates. Cool, guys. Yeah, so let me know if you need any help, but for now that is it. And you can always reach out to me. My username is Kirti_Sharma 1223. This is my username for Unacademy Messenger and Telegram. You can reach out to me here. And my code you already know, that is not this code, YouTube code here, right? That is Kirti S Live. This is my code, Kirti S Live. So you can use it to avail additional 10% off, and in order to enter in the class for free, special classes. Okay, so that is it for the day, guys. I'll see you in the next session, which is at 12 p.m. today. This session is at 12 p.m. for class 11, in which we will start GOC, General Organic Chemistry. We will start. Okay, that is it for the day. See you in the next session. Bye bye.